And you should be written that transgenic animals is an animal in which there has been a deliberate modification of the genome. It could be considered as a transgenic animal. An animal in which there has been, you have written that all? Yeah, I know. Have you written that?
No, teacher.
No, I see. I'm asking you to write just those which is very important. So transgenic animals, an animal in which there has been a deliberate modification of the genome. There are two approaches to create method 1 and method 2 to create the transgenic animal. DNA and embryonic stem cells are replaced in DNA of interest, replaced in the embryonic inserted into the embryonic stem cells, and then it's injected into the blastocyst, and then if these genes of interest spread in this blastocyst, so they are inherited, let's say, by this blastocyst, then it is put in the foster mother, which gets pregnant and then brings offsprings with the desired genes. And made heterozygous offsprings to produce homozygous transgenic strain also is possible. And then a second method, if during the fertilization two pronuclea, the desired gene vector is inserted into the one of the nuclei, for example, the nuclei of the sperm cell, and then they fertilize, the sperm fertilizes nuclei of the egg, and then this new transgenic animal implanted into the uterus of the foster mother, and these steps are then repeated. And these are 4 or 5 steps of transgenic organisms creation. Selection of artificial synthesis of genes of interest. So we should know what genes must be incorporated in our body. Finding and constructing of vector, which then brings this gene of interest, as we have seen over the previous period, to the body. Insertion of gene of interest into the vector. This is known technique, you know this all. Insertion of vector gene transmitter in organism of recipient, and selection of cells of or individuals which accepted the gene of interest. And you have seen it just now in the picture. And do you know that 1, 2, 3, 4, 5, 6 people in this room, no, not yet, 1, 2, 3, probably 4 people in this room are genetically modified? All of you. Do you know that? And who is this? No, sir. No. At least, I think at least, do you have children? Yes, so at least 4 persons here are genetically modified. Who? Me, yes. Who else? All women who have children. Why? Because of the genes of our children incorporated into our genome. And a few years ago, DNA of men was found in the brain of women who had delivered these children before. So they say this is the normal, and when we say that, well, when woman delivers a child, it renews her body, this is really, it has some practical evidences that it happens because the new cells of the human baby, the new DNA, in turn comes and incorporated into the whole body of the woman. That's why to be a mother is useful, because you, in some way, you renew your body, renew the tissues, you receive like the stem cell therapies portion, and we will see later in our lecture. And these are just portion of approaches or purposes for which transgenic animals have been used to identify the function of inserted transgene. Because if we insert some gene into the body of non-natural location, we can see how this gene works. It also can be used in toxicology. We can write purposes with you shortly. Identify the function of transgene. In toxicology, detection of toxicants, for example, on such modified organisms. In mammalian developmental genetics, for developmental genetics, to see how this gene acts during the embryonic development. In molecular biology, analysis of regulation of gene expression, which we have already spoken, analysis of the regulation of gene expression. In the pharmaceutical industry, targeted production of pharmaceutical proteins, drugs production, product efficiency testing. This is important. These animals can be as model animals for testing the action of different pharmaceutical products, and this model is very spread now and really highly used by pharmaceutical companies. I have spoken this year with some of the representatives of American pharmaceutical company, and they also use mouse model, for example, to check the action of new molecular based pharmaceuticals, drugs, to treat the allergic disease. But they use, for example, mouse model to check the action of these new molecules, and so this is a common approach. In biotechnology, producers of specific proteins, there are also these genes. Genetically engineering hormones to increase milk yield, meat production also. We apply these hormones. Unfortunately, it is we are not safe from all of this, and probably people apply these hormones to increase milk production, to enhance the growth of muscles in some animals, which then will be eaten, and genetic engineering of plants and livestock affecting modification of animal physiology and anatomy. And this is what is important, and this is the GMO-based food, for example, can be taken while using this approach. Cloning procedure to reproduce specific bloodlines, for example, but this is cloning of cells, not cloning of the whole body, and developing animals specially created for use in xenografting. Xenografting, this is transplantation. When we, for example, and you know that, probably know, probably not, that first animals used for transplantation for humans were who? Which animals were used in first? Not monkeys, but pigs, yes. And we can, for example, grow pigs with the desired properties to take then these organs to implant to humans, but it's good only if we are sure that this liver or, for example, kidney will not be rejected by our immune system, so it must be modified so that it consists of human-like genes, or it has human-like liver properties. And what is interesting, what is done in Ukraine, for example, a few years ago, they make them cows, which genes of human, of women, genes which are responsible for lactation. So these cows are able to produce milk which is similar for those which is produced by human. This is by women. This is also some of gene technology. Another way, another example of practical application, which is also widely used, and you, if you will be for good pharmaceutical agents or very good in your specialty, you will meet it, you will come across it one day anyway. This is the pancreas, and these are bacteria which are responsible to production. They have plasmids with gene of human, and this gene is incorporated into bacteria plasmids, and this gene responsible for production of the human insulin. This is common approach. Maybe 20, 30 years. This was also first when we're speaking about GMO food, we are speaking about the tomato, but when we are speaking about biotechnology for pharmacy, this was the first pharmaceutical approach which received practical application, yes, and successfully done in Germany, for example, and product which is made in Germany, this insulin, is very good, purified and so on. And you see that these bacteria have plasmids with the human gene of insulin. So this insulin human-like, and it is much better than those from cow, which was used before. Before this approach was described, delivered, and applied. So this is what you can see. This is our example with tomato. You see that genetically modified tomato, ordinary tomato after 20 days, after 45 days, and gene silenced with the two approaches. Silence of genes which are responsible for rotting, and second, add genes of jellyfish, which is also done to keep these tomatoes nice. You can transport them in frozen condition. After freezers, after refrigerator, normal tomatoes already will look like this. But yours, which are genetically modified, always will be nice looking. You will want to eat them, and they're really nice at first. That's why they sell you such type of product, and no one is safe, could be injured that we not eat it every day. For example, while especially when we buy these tomatoes in the winter here, when naturally they are not grown.
But is it healthy to eat
different approaches, and I expected such issues during our lecture, and I kept in mind that we should discuss it in practical, and some of you probably do, will be responsible for looking through different opinions of scientists, because there are two groups of scientists in the world. Some of them say, wow, it's dangerous, no, it's kill us, but others say no, everything is cool, great. So who is now has more worthy ideas? Let you tell us what is now the modern state of this issue. Let's see. But really, there are two different points of views. And you see the GMO food, which are sold in our salt, or we consume, or for example, cotton can be genetically modified yeast, oil, salmon, fish, and we will have problems, we will solve problems in practical class with you about salmon fish with extra chromosome, for example, which is produced in some Canadian farms, which are responsible for fish production. So you should be able to tell me what would be the result if the salmon will be, for example, thrown out from this farm to the nature, and what can happen. But still, they say, I don't see here soybean, but they say that up to 99% of soybeans in the world are genetically modified, unfortunately. And wheat, sweet, rice, everything is already in use for us every day. Very nice strawberry with by splicing them with fish genes. This is strawberry, which is made after splicing the, as we started with tomatoes and jellyfish, and we ended up with strawberry and fish. So why are you surprised? Everything is possible in our life. It's truly picture. It's not like Photoshop. It's not Photoshop. It's truly picture. This is the blue strawberry, fish genes, yeah, and strawberry, yeah. This is one of the. Do you want to eat this? No. I'm not sure I want to eat.
does it taste the same as the normal
I
straw?
haven't eaten that. And I'm not sure I want to do so, really. Do you want it?
No.
If you eat, you'll be
Она
avatar.
I will be blue as well, yeah? So you will be responsible.
Вікторія Володимирівна, на вкус. Як рибка,
То вже ж питають мене, я кажу, що я
я
ні, там
Too
in the
expensive.
description, yeah, not expensive. In this description I have found it, yes, and in the description they say that fish with taste of strawberry or strawberry with taste of fish. I don't know, probably it has some taste of fish, but we should try it, we should sample it. And this is the not final, but almost final portion of our lecture. We have a few minutes and it's enough to us. So, cloning, process of, and you are writing down very intensively, what is cloning? Is the process of creating, this is also next approach of biotechnology which we are discussing today. So this is the next application which also is done, is used, and we will see how. Cloning is the process of creating identical copy of original organism or thing. The term clone is derived from the Greek word for twig. Twig is small branch, and grafting, for example, or horticultural cloning is that when we take some twig from one plant and then put it into the soil and we receive the clone. Clone, what is clone? Okay, yeah, I will put and be for you. Clone is identical copy created intentionally. Clone is identical copy created intentionally. Cloning is process, you are writing that, of creating identical copy of original organism or thing. And you can stop here. We just need the definition. And clone, what is clone? Is identical copy created intentionally. Clone is identical copy created intentionally. Process of creating an identical copy for original organism or thing. Clone is identical copy created intentionally. Cloning. However, it is wrong to think that cloning could be usually in common parlance. We say that clone is artificially done copy of some body, of some living being. However, nothing is new in this world, and cloning existed for many, as the same period of time in which living being exists on the earth. Because the natural cloning, this is asexual reproduction. You can write this: cloning could be subdivided on natural, which is asexual reproduction, and artificial. Cloning subdivided on natural one, which is asexual reproduction, and artificial, which could be of 4 types, for example, horticultural, for agriculture, genetic, for colony of cells, reproductive and therapeutic, we will study them. So we need with you just this portion: cloning, natural, artificial, asexual reproduction, horticultural, genetic, reproductive, therapeutic. Natural, artificial. Natural is asexual reproduction. Artificial includes horticultural, genetic, reproductive, therapeutic. And we will now discuss this all, so you don't need to draw it, but this portion is important. The upper part. For human clones. How do they appear? Cloning in the but this is explanation. Cloning in the biological sense results in molecule single cell or multicellular organism has been directly copied from and therefore genetically identical to the molecule cells or organism being cloned. Sometimes this term can refer to natural clones, which may arise when an organism reproduces asexually by chance, as with identical twins. We studied with you previously in biology, and you see your previous knowledge are important. How can we get these 4 human clones? Do you remember? How is it possible? There are 2 types of twins. 2 types of twins.
So one is similar.
Identical and non-identical. So these are identical. How can we get them? First, everybody of us started from one cell, single cell. But then this cell is called, what is the name of the cell? Ovum and egg together produce zygote. And then this zygote divides. And if it splits at the level of 4 cells, every of these cells is able to produce single organism. Due to, and we studied it with you on cell biology, due to the totipotence. Totipotence means that the cell is able to produce the whole body. And this totipotence remains up to end of the morular stage. So these 4 cells split it, and every of it developed as a single individual. And we are speaking about natural clones. And this is the only truly clones which can exist. Those videos and movies which tell